with just a quick high-level overview into Subspace. That'll be from Jeremiah, our CEO, and Nazar, our CTO. From there, we'll then start diving into questions and everything. Discord will automatically put you in line, so at this point you can start clicking the little raise your hand button in the middle of the event stage, and that will put you in line for questions. We're just going to do a first come, first serve as far as the event stage questions go. Beyond that, go ahead and take it away, Jeremiah.
Awesome. Thanks, Justin. Can you hear me?
Yes, we can. Yes.
I can.
Great, great. Okay. Well, thank you, Justin, and thanks to everybody on the team who helped put this together, and thank you everybody who's here. Really looking forward to getting to talk to everyone in the community and answer the questions that you all have. So my name is Jeremiah. I am the co-founder and CEO at Subspace Labs. In case you're not aware, we are building the Subspace network blockchain. Subspace Labs, currently we have a remote team spread all over the world, about 7 different countries right now. We have 12 full-time team members. We've been around for a few years. This is our 4th year on the project. We have primarily been a research and development project for quite a while until recently. We started really building the blockchain. And we have been kind of obsessively focused on solving some of the core systemic problems in the industry, in the blockchain space. Things like the energy efficiency or environmental sustainability of blockchains, how to operate at global scale in order to support mass adoption, how to handle this increasing centralization that we're seeing in the industry, and how to do all this while maintaining security. So these are the things that really get us up in the morning that we really care deeply about. So we're building Subspace, a blockchain, to solve these problems. Subspace is a new layer 1 blockchain. We consider it to be the first 4th generation or Gen 4 blockchain. And what we mean by that is first generation, obviously Bitcoin. Ethereum was really the next major upgrade, the next improvement in the idea of blockchain. There's many competing 3rd generation protocols. You've got Polkadot, Near, Solana, Cardano, Ethereum 2. All of these make a series of trade-offs in order to achieve scalability on this so-called blockchain trilemma. And we call ourselves a Gen 4 chain because we fundamentally overcome this trilemma. We don't have to make trade-offs in order to achieve scalability. And so we are, in our minds, and we look very closely at what other people are doing in the industry. We follow very closely. We believe we're really the first blockchain that can really achieve global scalability. What we mean by that is we can support mass participation in consensus by ordinary people with commodity hardware. So this is kind of back to the ideal of home mining that that Bitcoin started with, but we're doing this without the waste, without the electricity cost of doing this. We can support mass adoption on the user side, so we can have billions of accounts, billions of transactions, millions of transactions per second, actually. And we can have blockchain-based decentralized applications that can actually run at internet scale. So Subspace, as a blockchain, it's really just a platform for both storage and compute, so meaning smart contracts, that is just fundamentally a new level of scalability. The kinds of things that we think that platform will be used for, the kinds of things that we're really excited about, and that our chain is really, really well suited towards, probably are going to be built around NFTs. The ability to not only mint an NFT, perhaps on Subspace, perhaps on some other chain, but also to store the data associated with that NFT, so that data doesn't have to be stored on a centralized server or controlled by some company that issues the NFT, but that data has the same permanence as the NFT itself. And then the things around that with like gaming and the metaverse and many of these other NFT use cases, which ultimately just boil down to billions and trillions of NFTs one day, with lots of data associated with them. So that's something that we think that's what we think is really going to be one of the killer apps or key use cases of Subspace. in the future, but it's really a generic and abstract platform at the end of the day. Yeah, so that's kind of a high level about Subspace. I'm going to turn it over to Nazar and let him talk a little about why he's excited about Subspace.
Absolutely. Um, Thanks for coming, guys. I'm Lazar. I'm also a co-founder and CTO at Subspace Labs. I think one of the most exciting things about Subspace, and I'm biased, of course, is that in contrast to many other projects, we fundamentally do not accept the blockchain trilemma. We do really think that you do not necessarily have to make trade-offs between scalability, decentralization, and security of the network. You can kind of have all of that in one place. And in order to achieve that, you need to really go into the fundamentals and start from the first principles to design a network which has a fair consensus, which is based on the resource, which is widely distributed, which is storage. Ideally, that resource shouldn't be wasted. That's why our consensus is actually proof of useful storage. We call it proof of archival storage, where all of the blocks and transactions that people submit to the network will be archived by the farmers. That I expect most of you guys will be doing. And then, proportionally to how much data you store of the history, like the useful service, objectively, proportional to that will be your chance of winning the farmer block reward. And we believe that decentralization is very important, and that is why all of the blocks that we have and all of the farmers that will be competing for the block rewards, all of those rewards will go to farmers in the first place. This is like a big part of the tokenomics of the project. So really believe that is a key part, in contrast to some of the networks which are using proof of stake, which is basically permissioned environment where you need to have coins in order to participate. On the other side, like storing data, fine, having consensus is cool, but we also do want to have some computation on the blockchain. That's the big innovation that Ethereum brought to the table. And we have several parts to that. One is the decoupled execution, where farmers, they do produce blocks, but they do not run the blocks. That's why farming is very energy efficient, and anyone can basically do it as soon as they have a little bit of space. But there is another role on the network, which is executors. There are a bit more powerful machines, like gaming desktop computer, that can run transactions and earn rewards, like a fee from the transaction execution. And those will also be distributed, probably a little bit less than farmers. But important to remember is that even though those nodes are powerful, the control over the network is still in the hands of the farmers. This is a big distinction between proof of archival storage that we have and proof of stake, where executors are kind of like validators on those networks, but validators control the network. In our case, farmers control the network. All that executors do, they just deterministically run whatever farmers decided to do. And one part of the protocol, which is not very well described right now on our website, but it is kind of mentioned on the technology side, is the scalability. So ability to scale vertically is something that we do have in the white paper and on the website, where executors can run basically as many transactions as they can afford in terms of CPU, bandwidth, and other resources. But we also have an interesting design which flows from this decoupling of farmers and executors, which allows us to have a pretty unique horizontal scalability. And that is the part where if you have, let's say, 1,000 transactions per second on one shard, which is not amazing by today's standards, there are networks that do more, but let's say the conservative number, if you add 1,000 shards, that's 1,000,000 transactions per second. And our network is designed fundamentally such that it allows to have basically as many of these shards as we have executors on the network, and still have decentralization in terms of consensus, because consensus is done globally, in contrast to some of the other networks where you have to split block producers between shards, and there are some security implications of that. So I think this is like unique combination of both sharding of execution, of storage, of processing, and scalability in terms of consensus participation. Like all of that together is a pretty unique combination that fundamentally overcomes the famous blockchain trilemma and we don't really believe that it is true, and it has to be that way.
Awesome. Thank you guys for your intros there. Let's go ahead, and if people want to start asking questions, they can start raising their hands in the audience here on the event stage. Should be an option for you at the very bottom. And while we wait for that to line up here, we do already have some questions in the chat. Rogue Peter, they asked, what are some competitors that exist or are already in development currently to Subspace Labs, or the Subspace network?
Yeah, there, depending on which aspect of Subspace you're talking about, there's definitely people or projects that are doing similar things. So, on the consensus side, with what Nazar was talking about with proof of archival storage and farming, Chia and Filecoin would be two of the biggest competitors, I guess you could say, or maybe comps. And the real difference is that we're really aiming for to be as permissionless as possible. So like in Chia, in Filecoin, you have to stake. You also have to have some very special hardware. And it really only supports this storage use case. It doesn't have generic computation or scalability built into it. Chia, they're much closer to our ideal of this permissionless consensus. But at the end of the day, in practice, they burn through SSDs and they require a lot of energy in order to do the plotting. We've really carefully designed our plotting so that it's much more energy efficient and it works on any hardware. And Chia kind of supports like improved Bitcoin style smart contracts, but it's not like a global computation model like Ethereum. And again, it's not designed for scalability. These are kind of both really like fundamentally like layer one blockchains that just have a different consensus mechanism, or sorry, not layer one, Gen 1 blockchains like Bitcoin that just have a different consensus mechanism. Arweave is something which we get compared to on the storage side a lot. Nazar, I'll let you take that one.
Yeah, on Arweave side, they did a great job in terms of offering the archival storage, but fundamentally they are also kind of like the first generation of storage networks. Because of their architecture, it's not really possible to increase the throughput like we can with sharding. Basically, let's say if you have like 10 megabits per second per shard, and we have 1,000 shards, suddenly we have almost 10 gigabits per second of upload that we can do to the network. And that will scale with number of participants on the network instead of getting slower. So this is like, basically you can consider Subspace as like an evolution of that idea. And also importantly, in our view, you have the process of mining. So you still burn CPU resources to participate in block production. Storage is kind of like a side feature. For us, the storage is the like primary mechanism. We don't have to burn electricity just to participate in block production. Your storage is your ticket.
Yeah, and one other comment on Arweave is the pricing model. This is really one of the key innovations which we introduce. We have a dynamic cost of storage. So it responds to basically supply and demand. You can think of it like an automated market maker for on-chain storage. Whereas in Arweave and pretty much all blockchains where you're storing data directly on the blockchain, there's a fixed cost of storage. And this is like Satoshis per byte in Bitcoin or like Gwei per byte in Ethereum. And it doesn't change really. In our case, it changes based on how, like supply and demand. Like we can actually measure the space pledged to the network as part of consensus. We can also measure the demand. That's just the size of the blockchain at the end of the day, because everything's just being written into the blockchain, all the data that's being stored on the network. So this is really incentive compatible, the most incentive compatible, and it also means that as we get more adoption on the farmer side, that the cost of storage actually gets lower. And it becomes more attractive, becomes more, more economical, which just drives more adoption. So you get this kind of virtuous cycle.
Awesome. That was perfect. His follow-up was also with Arweave, so you guys nailed that one there. Next question would be, when do we plan on opening up the testnets to the community?
Well, I would say technically it's already open. We just haven't really been talking about it. So if you wanted to, you could go and just run the instructions that are in a GitHub, and you could run a node on the network. But just to be clear, it's not incentivized. So there's no rewards for doing this. We're still working out bugs in the protocol. We're still trying to improve the user experience. It's going to be breaking continuously, like probably on a weekly basis. We're still breaking our testnet as we make upgrades and changes to it. So really anybody is welcome to participate, and we would definitely welcome the feedback. If there's anybody that's like a tester out there that loves to like play with these new protocols and give feedback, we would welcome that. But we're not really going to be announcing community farming and trying to build up the community, probably, for at least for a few weeks. But our next major objective is going to be launching an incentivized testnet. We still don't have a firm date for that yet, but we're trying to get it out as soon as possible.
Yeah, our team internally is already like all running Farmer and Node implementation, and we are testing how things work. And I know some people from the community already found the repository and just went to instructions and successfully joined the network. So that was awesome to see.
Awesome, thank you. It looks like we have a question from Folk here. Let's go ahead and bring him up to the stage. Go ahead.
Hello. Hi, guys. Hello?
Yeah, we can hear you.
Oh, okay. Sorry about that. So I just have a quick question about the NFTs. I'm not very tech savvy, so the answer may be obvious, but just, bear with me. So let's say I mint an NFT on Solana, Avalanche, or I don't know, Secret Network, or, something else. Why would I store it on Subspace instead of the original chain? I mean, what is the advantage?
Yeah, that's a great question, and I thank you for asking it, because it's not always obvious to people. So there's really two parts of an NFT. There's some ownership data about the NFT, which has to be tracked on the blockchain, like that's the asset data, and then there's some metadata or some content data that's often associated with it. So if it's like a PFP, there's like an image, or if it's an audio file, if it's music, there could be an MP3, or it could even be a video, or if it's like a metaverse object, it could be some like asset file. And blockchains are really, it's very expensive, bottom line, to store this data. Like it's like $100,000 a megabyte or something like that on Ethereum right now to store data. It's cheaper on other blockchains, but even those are really not optimized for storing that data, and they tend to not be stored on the blockchain. They tend to be stored on some like centralized provider, maybe hosted on IPFS, but not guaranteed to be on IPFS. And so we're not saying, we're still saying put the asset data on that chain, but put that file data on Subspace and give it the same permanence, so that if that business shuts down, or if that IPFS node gets turned off, that data is still available.
Okay. So it's also about security. So it's like double security, let's say, just in case the actual thing gets destroyed in the original chain.
Yeah, you could say security. It's also like immutability, permanence, just longevity. Like as long as the blockchain exists, that data will exist.
Okay. Thank you very much.
Of course. Thanks for coming up. Alrighty. Looks like no one else has their hands up in the audience here. We'll go back to the chat. Next question we had here is from one of our ambassadors, actually. Knacker is wondering, what is the advantage of splitting executors and farmers?
That's actually one of the components that allows us to have high decentralization on the consensus side. So imagine when you have farmers, which not only have to produce blocks, they also need to run all of the transactions. This is basically what happens in Ethereum. And then every node who is the farmer would have to have the hardware capabilities to run all of the transactions. Or in other words, the throughput of that blockchain will be limited by the slowest computer that is on the network, right? And that is why Ethereum, for instance, they cannot just crank the transaction throughput or the gas limit on every block to however high a limit they want. They need to target a specific machine, right? And because of that, they are limiting the amount of computation that can happen every block. Once we have a split, we basically segregate the responsibilities. We can have very lightweight farmers, which can participate in consensus and offer security to the network. But we can also have more powerful machines, a bit less in terms of the number of machines that will do computation. And those machines that do computation, they are not responsible for security. They are only responsible for liveness. So that is the approach to allow more work to be done every block without overwhelming regular farmers.
Awesome. Thank you, Nazar. We have a question, another one from Rogue Peter. He says, what happens to data with prohibited content that is hosted onto the Subspace network? Specifically, illegal pornographic material, etc. Will there be a policing feature to delete files from the blockchain? And if not, what are the legal implications for farmers running a farmer node and users?
It's a great question. So we're really big believers in decentralization and being as permissionless as possible. And once you start trying to censor, content which you think is bad, or once you add the ability to censor content, then it can be used, to censor other content, because it's a very subjective question. I'm not saying, the stuff you're saying that you're proposing, it should not be, that it shouldn't be supported, but it becomes very subjective about, well, what is and what is not censorable. And so we are not planning to implement anything directly to control this. We're just building a reference implementation of how this blockchain should work, but it doesn't stop somebody from building another implementation or submitting a pull request. This is all open source, right? They can fork it, they can clone it, they can submit PRs. We're working on a subspace improvement proposal process, so that could be an SIP, and this is kind of up to the individual how they want to handle that. As opposed on the legal side, I'm not a lawyer, I can't answer that. Of course it depends on what jurisdiction you're in, but it's definitely it's a regulatory question which many governments are grappling with right now.
I can probably answer from a slightly different angle. The way data is stored on the subspace is you're not storing like files. The history of the blockchain is actually split into multiple chunks. And then you as a farmer store random selection of those random chunks in a specially encoded way. So it's not like you are storing a particular file. It's more like the network as a whole stores some content. So take that as you want.
Awesome. Next question was Peter Lee, wondering if we have any hackathons or developer grant programs.
Another great question. We do not have any hackathons planned right now. We've actually been attending some hackathons, building out some protocols or some ideas we have using the Subspace API, the JavaScript SDK that we have. And we do not have a grant program yet, but we will eventually. We will eventually have hackathons. I'm saying conservatively, maybe in the next 6 months, we might have our first hackathon. Grant programs will probably come closer to mainnet launch after we've done a community sale. That's where that grant, where the funding is going to come for those grant programs. But it's definitely something that we have on our roadmap.
Awesome, thank you. Next question is from Ja Gend. He is wondering, where is the data stored? He saw that storage was separated onto our white paper and was curious about a clarification there.
It is stored on the blockchain. It sounds ridiculous to some people that are coming from like Ethereum background, but basically what you do is you put your data into transaction, submit transaction to the network, and transaction gets included into the block. And then that block is archived as part of the regular history, and that's how you store data.
Yeah, and just to expand on that, like if we were like Arweave and we were just a single blockchain, where everybody stored like a full replica by default, that wouldn't scale very well. But there's a lot of our protocol that is designed around basically kind of at a high level the way like a data center works when it shards data across a bunch of different computers. We just do this over a network level, and we do it with cryptographic incentives. But effectively, like Nazar said, this data gets chunked up, it gets erasure coded. There's a load balancing policy. There's like a decentralized retrievability policy. So like all of this stuff can still be like found and like still coexist, even in these like tiny little chunks that are like spread to the four winds across the network. So any particular node that's storing the history, it doesn't really matter. They don't have to have as much as the whole blockchain history has. They just have whatever percentage they have. If they have enough to store 1% of the history, they store 1%, and then they get a percentage of the block rewards based on the total storage across the network. If they have more storage than the network, than the blockchain is, they could store multiple copies because they're storing unique copies. That's really an important part of our protocol. People aren't storing the canonical copy of the blockchain. They're storing this transformed copy, this permuted copy, which and they're proving they're doing this. They're proving they're storing it in this unique replicated fashion. This is how consensus works.
He had a couple follow-ups there. In that case, how do we avoid slow transactions that might occur? And how do we avoid data accumulation, such as like a congested chain?
I think answer to both of those is sharding. So when you have one chain which is very congested, that basically means that there is more work to do than whatever one chain can do. And you can add another shard. So let's say we have one shard and we can support X transactions per second or X megabytes per second. But there is more demand. We just add another shard and then we can split the load in half. And depending on how much demand there is and how many farmers and how many executors we have on the network, we can just keep adding those shards as needed. And that way we can scale.
Awesome. Alrighty. And we had one from another one of our ambassadors. Alphanomicon is wondering, what is our thought process with onboarding other blockchains? How do we convince them that using Subspace will improve their experience with their particular blockchain?
That's a great question. And the answer is we don't have to approach them. We don't need their permission, right? It's the beauty of blockchain is that this is all public data. It's all permissionless. We can kind of just integrate at will, or even our community or developers could extend our protocol to integrate at will with any other blockchain. It's kind of like with Uniswap. They just built a protocol. Anybody can add a token pair to Uniswap. That's kind of how we designed the way Subspace integrates with other blockchains. So we've built this for Polkadot and Kusama with the relayers that we have right now, kind of as an experiment to make sure that this would work. But we've done it in a generic way, and we've certainly worked hand in hand with a lot of teams, directly with Parity, somewhat with Web3 Foundation, and with several of the parachains, to get feedback on this. And everybody's been very supportive of this. Gavin Wood even talked about it in one of his last newsletters he sent out. But we're kind of taking the approach of doing this one ecosystem at a time. So .sama was the first ecosystem. Ethereum is going to be the next ecosystem. And we definitely want to get buy-in and consensus, from people, from that community, specifically from like the developer and the protocol engineer community there. But we found that everybody's been, very, very welcoming and excited about these things, versus seeing it as kind of a threat, because we're just helping them scale, helping them be more decentralized.
Awesome. And just a real quick refresher, everybody, if you would like to speak in the event stage, there should be a request to speak button in the bottom middle. That'll put your hand up and we can form a little line there if there's any further questions. While we wait, we do have one from a question we got a little bit ago that was also from Alphanomicon. Will there be a capped supply for the token?
Yes, there will be. Yeah, it's a cap supply. The current tokenomics is effectively Bitcoin style halving, just more frequently. Right now, that's 1 year every time there will be a halving. Another important thing about the tokenomics, like Nazar mentioned, the over 51% of the token supply is going towards farmers, towards the community. The executors are only getting the transaction fees; they're not getting the new money that's being created. This is all going to be part of our token white paper, which we hope to be releasing in the next few months, hopefully, but we'll see.
Awesome. Vinny East is wondering, for farmers, if it's better to use hard drives or SSDs.
We made farming process as lightweight as possible. So there is really no demand for like powerful CPU or fast SSD. Regular hard drive should be just fine. If you have some slack capacity on SSD, that's totally fine as well, but it might not be economically viable or reasonable to buy SSDs for that purpose. It's more targeted at like the slack capacity that you have already lying around. Let's say you have a hard drive for games, it's a few terabytes, and you have like half of that empty, so you can just use that to farm some Subspace credits.
Awesome. And I'll also add too that SSDs have a limited lifespan compared to a hard drive. While it is physical, it doesn't necessarily have a hard cap like an SSD does. Alrighty, do we have any other questions? One question I had been asked prior to from another user who couldn't make it was, is there going to be any internet speed requirements for the network?
Yeah, that's a good question. So it kind of goes back to what Nazar was saying about, having like low bandwidth requirements for farmers or low hardware requirements for farmers. So, so kind of in our protocol, we can really make this whatever we want, but the higher the bandwidth requirements or the internet speed, it's not so much the speed, it's the throughput. The less decentralized it's going to be, the more centralized, the harder to run a node. So we're gonna try to keep this as low as possible, and effectively we look at this kind of as a community decision. So there might be a parameter that could be soft forked or done. Since we're using Substrate, this would be a forkless runtime upgrade to control this. So just kind of like in Ethereum, where the miners get to vote on what the block gas limit is. That's more about the CPU bandwidth than the network bandwidth, although they're related for sure. But we're basically going to keep this as low as possible. So even if you're in in a country or a part of the world that has bad internet, you should still be able to participate in farming.
Awesome. And the last question that I have from the backlog, at least, is what is the farmer's dilemma?
Farmer's dilemma is one of the problems that some of the earlier proof of capacity, like in general, consensus has had. For instance, GA is susceptible to this. The basic idea is that you have several things that you need to store for the blockchain. You have the history, you have the state. And if you have a proof of capacity blockchain, you also have the capacity that you provide in order to participate in block production, right? And essentially, you have one like pool of storage, like you have one disk, and you need to store both. You need to store some space, occupy some space to participate in consensus, and you need to store the blockchain data. And since your reward as a farmer depends on how much space you can provide to the consensus, the logical choice is to not run a node or run a light client instead of the full client and not store the whole history, do not store the whole state, and probably join just the farming pool in the end. And that decreases decentralization of the protocol drastically because then only farming pools, which is very few comparing to number of farmers, will actually store the history of the blockchain. Or alternatively, only light clients will be around on the network for the majority of farmers, and they will again only store a small portion. They will be able to validate that things are correct, but there is really no guarantee that the history is recoverable. And basically, this is called the farmer's dilemma, like what farmers will prioritize in terms of like their reward. And by using proof of archival storage, we just flip this problem into a feature where the thing that you are storing is the blockchain itself. So you don't have to decide what you want to store, right? You are storing the blockchain, and that is what you need in order to participate in block production. And this is like another like small part to the decoupled execution that executors will store the state, like the balances of accounts, how much coin everyone has, and that kind of thing. And the state on the farmer side will be very, very small. So there will be no incentive for farmers, or there will be very little incentive for farmers to not run a node and secure the network, because that will be like the default behavior for them. I hope that makes sense.
Yeah, and another way to think about that is like this problem of centralization in blockchains and economies of scale. And what we've tried to do and what we believe we've achieved is to remove any economies of scale from farming so that there's no incentive to like pull your disks together or even to go out and buy disks for that matter. The only incentive would be just to reuse slack capacity that you already have on the network. And one of the big lessons that we've learned since we released the white paper is that this farmer's dilemma is actually just a special case or an instance of a much larger, much deeper problem, which is the problem of blockchain bloat, which basically all blockchains suffer from. That as this state blows up, several hundred gigabytes in Ethereum right now that you need to maintain the state. As the history blows up, I think it's 9 terabytes to run an archival node on Ethereum. This leads to increasing centralization on its own. Even though there's not a direct economic incentive, like in proof of work, proof of stake, you're not penalized for storing this data. Whereas like Nazar is saying in proof of capacity, you actually are penalized. There's a disincentive for storing, using your disk for this data. It still just becomes burdensome. And this is this problem of bloat, which leads to more centralization again, and or everybody running a light client, and there's just a completely different security model. Like all the things we talk about, like with Bitcoin, like the honest majority assumption or the safety of Bitcoin, the immutability of Bitcoin, these things don't work in a light client model. It's a whole different security notion. You can double spend, you can mint money out of thin air. There's all these things you can do if everybody's a light client. This is why people care so deeply, about like why Ethereum, like the whole Bitcoin civil war, right, was about this like block scaling debate. The whole reason Ethereum has really resisted scalability on layer 1 and pushed to the L2s and to the rollup solutions is because they're concerned, and Vitalik is like very very outspoken about this, about maintaining the ability to run a node on like an average developer's laptop, to run like a full node. And what we have done, like when we solved this farmer's dilemma, we did it specifically for how do we have a fair, decentralized proof of capacity consensus protocol, but more generally, we solve this problem of scalability. Like as you scale, as you have thousands of transactions or millions of transactions per second, this history in this state grow tremendously, right? And then nobody can run a node, or at least everybody has to run a light client. So we were able to sort of take this work we did around this novel consensus and apply all of these amazing scalability techniques that other protocols have been working on, that the broader blockchain ecosystem has worked on, and specifically some researchers at Stanford that we've been working very closely with. And we can implement them, and we can scale, and we can still maintain decentralization. We can resolve this problem of bloat.
Awesome. Thank you for that in-depth explanation. It looks like that's all of the questions we had. For some closing notes here. Last call, if anybody had any last questions. We have time for probably about one, maybe two more. All right, looks like we got some people typing here. While we let those last questions come in, I did want to take the time to mention that we actually just opened up our ambassador applications for our second cohort of ambassadors. So we're going to be bringing more people on. As an ambassador, you're just basically an but a community representative of Subspace, trying to bring people in and helping us build out, the grassroots community we aim to build with everybody. We went through our first cohort, and they've been doing great so far. They're starting to get a good structure established for the ambassador program, and we're just excited to bring more of you in. In the general chat, in the event chat, you will see the message with the application if that's something you are interested in. We'll also be going. Go ahead, Jeremiah.
Sorry. I was just going to say, if we're waiting on a few more questions, just a few things I wanted to say to anybody in the audience that's looking to get involved. Ambassadors is definitely a great way. Running a node on our testnet or on our farmnet, being on the lookout for a broader community farming network. We're going to be more vocal about that soon. Follow us on Twitter, get involved in our Discord, in our Telegram. All I can really say is there's a lot of cool stuff, a lot of cool announcements that are going to be coming out soon. A lot of very, very exciting things happening behind the scenes at Subspace, and just a little too early to talk about right now. But yeah, you guys are all pretty early in this project, but there's a big vision, a very aggressive vision that we're getting ready to start implementing here.
Awesome. And looks like the last question pertains to from Rogue Peter. He is wondering, in regarding his question about prohibited content, is it possible to determine exactly which farmers are hosting which specific chunks of data? I think he's referencing how some of the Arweave farmers were targeted by the Chinese government.
Yeah, I think it's not really directly possible. Like there is logic that is in the implementation that kind of implies you'll be storing some pieces, but you're not really required to. And we expect there will be alternative implementations eventually for this kind of thing that will be able to apply some policies. But otherwise, you're just storing 4 kilobytes of random data in large quantities. You don't really know what it is. It's just random data for you until you know what it is and how to interpret it and how to assemble together. Until then, it's just random bytes that someone may or may not store.
Yeah, and I guess just to expand on that a little bit, there is a retrievability aspect where you can reconstruct like objects or files that are put out onto the network. It is very, very highly distributed though. So, it's not about like knocking out a farmer who has some file. It's about knocking out hundreds or thousands of farmers who have all of the different chunks, and you don't even need, you have to take out like over 51% of the chunks basically because of the way the erasure coding works. So it is theoretically possible. Practically, it's very, very hard to do, especially with the levels of decentralization that we expect to see and the levels of adoption we expect to see in the farmer network.
Awesome. Well, it looks like that is all of our questions. Once again, thank you for coming, everybody. We really appreciate you stopping by on our very first community event. As Jeremiah mentioned, make sure to follow all of our social medias. We're on Twitter. Give us a follow or a star on GitHub, and just keep up to date with our Discord and Telegrams because we do have some exciting stuff coming up. And other than that, hope everybody has a good rest of your week.
Thanks, Justin. Thanks, everybody, for being here.
Of course.
Thanks, everyone. Have a good day.
You as well.